are worthy of insurance because we know how to drive.
Okay, so this is a yellow light. The go zone is all the positions the car can safely pass through an intersection during a yellow light.
Really with a yellow light, there are going to be some factors that are involved with it, but generally the go zone is where you can continue driving and you will safely pass in the intersection without hopefully dying.
This is the equation for the go zone. It's v times ty minus the w and x velocity times the yellow light time minus the width of the intersection. And that's just a little practice problem. And then this is the stop zone and the go zone. As you can see, the go zone, you're closer to the yellow light, so you have enough time to actually get to the intersection. In the stop zone, you will not have enough time to get to the intersection. This is the stop zone. This is the positions from the light where you can safely stop without entering the intersection.
If you were to go through this zone and you were to try to make it through the intersection, you would not make it through safely.
And that's the equation for the stop zone. It's v times t plus v squared divided by 2a. V is velocity, t is time, and then a is acceleration. And that's another practice problem. And then there's a dilemma zone, and the dilemma zone is where no matter what, the car cannot safely stop or go, and car M would be in the dilemma zone.
Pretty much the dilemma zone is if you were to try to make it through the intersection, you might not make it on time. I mean, you may if you sped up enough, but if you were to try to stop, you might get whiplash because you have to stop so hard on your brakes.
Once you do a curve, this picture down here shows the centripetal force. That centripetal force is what keeps an object going in a circle. And if there was no centripetal force, then the object would just go in a straight line.
The centripetal force when you're driving is the friction from the tires on the road.
And that's, no, just ignore that top part. The centripetal force is a mass times the velocity squared divided by the radius of the turn. Centripetal acceleration is the rate of change of tangential velocity, and the equation for centripetal acceleration is velocity squared divided by the radius of the curve. And the circumference is the distance around the entire circle. So, I mean, just talk about a curve, and you can't really see the diagram, but there's actually a circle there. And to find the circumference, you do 2 times pi times the radius of the circle. These are just some sample questions that we put on there. And we're supposing that the mass of the car is 1,000 kilograms. It is going 27 meters a second, and the radius of the curve is 100 meters. So to find the centripetal force, you take the mass is 1,000 times the velocity squared, which is 27, and you divide it by 100, and you get 729 when you square the velocity. So you multiply 1,000 times the velocity squared, and you get 729,000, and then you divide it by 100, and you get about 7,300 newtons. Yeah. Okay. So centripetal acceleration is velocity squared divided by the radius, and yeah, pretty much. And circumference is easier to solve for because you just plug it into your calculator.
Okay, so this is following distance. Following distance is really just how closely you are following the vehicle in front of you. Most insurance companies say that 3 seconds is a nice stopping, or like a nice following distance. So what me and my mom like to do is whenever she's driving down the road and we hit a stop sign and there's a person in front of us, she will wait exactly 3 seconds while they're going, and then she will start driving. Because for 3 seconds, a lot can happen. So if you're just following even 3 seconds behind, you can safely stop once you start actually going at the normal speed.
Braking distance is the approximate distance traveled before coming to a complete stop when the brakes are applied and a vehicle moving at a specified speed. And in between braking distance is a thinking distance, which is also also like the reaction time. So at varying speeds, the reaction time is greater or lesser. Factors that affect braking distance would be speed, road conditions, car conditions such as the brakes, whether they're new or old, if the car's full of people and if the tires are bald or not.
I mean, the reason that is because really there's only the friction between the tires and the road. So if the road conditions are bad, that's gonna throw off your friction. And if your tires are bad, that's also gonna throw off your friction. So total stopping distance is the distance, the sum of the reaction distance and the braking distance. And this little diagram can just show that, I mean, even if you're not going that far, it's gonna take you that much longer to actually stop.
Reaction time is the amount of time it takes to react to a situation. And factors that affect reaction time include age, fatigue, physical fitness, alcohol/driving under the influence, and gender, road conditions, and weather conditions. Because if you're older, if your reaction time would be greater. If you didn't get enough sleep, it could also increase your decrease your.
And then, I mean, if you're physically fit, like if you're healthy, you're gonna react quickly. I mean, if you're driving under the influence, you're gonna have depressants in your body, so you're gonna be going slower, which means that your reaction time is gonna increase. Gender, they usually say that men are faster at stopping than women. Road and weather conditions, that's just self-explanatory, really. I mean, it'll be harder to stop in fog. Like if you don't see something coming, you're gonna have to react quickly, but you may not be able to.
Good job.